little longer. Hello. Isn't this exciting? I find it very exciting. And we're going to talk a little bit today about some of the things that I believe will help prepare you for the rest of this summit. You've heard a little bit about skill sets. You've heard a little bit about mindsets, about tool sets. And I'm here today to talk to you about mindset, because I believe that at the end of the day, that is the most important thing. You can buy and make all the tools you need. You can learn all the skills you need. Humans are very good at learning skills. Mindset, mindset, mindset. If you walk away after 2 days, understand an exponential mindset. Let's see what we mean by that. If we could, there we go, put our first slide up here. Do we have it? I think, oh, it's right behind me. Sorry, my bad. What we're looking at here is a glass plate of a photograph. It was taken in the early 1920s by an astronomer named Edmund Hubble. We've heard of Hubble. We've heard of the Space Telescope. Up until this photograph, humans thought the entire universe was the Milky Way galaxy. Hubble took this photo, looked at the little fuzz, the dot up there, and said, oh, that's a variable star, because that's what astronomers were looking for. But then he realized, wait, that's a galaxy. It's not just the Milky Way galaxy. There are dozens of galaxies. Of course, now we know there are 2 trillion galaxies that we can see. And I share this with you because I want you to remember that things will change and your world will get much bigger. And that you should take a lesson from this in, it may not be what you think it is. However, there are things you can do to help predict, to help look ahead into what's next. And that's what you're going to walk away with from this summit here today. You're going to realize that it's a much bigger place than you thought. Okay? The one thing I can guarantee, this happens all the time, is that tomorrow will be nothing like today. And it can be a little scary for people sometimes. Here's an example of someone who's experiencing technology that's new and different for the first time. It's an autonomous vehicle. Watch this.
It's scary. Oh, there's cars coming. Oh, there's cars. Ah. Bill, just put me back for me control it. Oh, dear Jesus. I could never.
Okay, it's a little scary, and there are a lot of technologies out there that we might be scared about. And we go to the movies and we see robots, and they're going to come from the future and get us, and it's frightening. And so we should understand that these technologies can be a little frightening to some people. We're all here today, and hopefully they won't be, but you need to understand what's going on with our technology, right? Because it used to be that we had this, and now we have this. It's very different. We used to have this in many of the cities of the world, and now we have this. And there's many examples of this, including this in 2007.
Today, Apple is going to reinvent the phone.
And so a company that has never made a phone before makes a phone. Here's something else from 2007.
Nokia devices will allow you to touch the screen to navigate. Browsing your content couldn't be easier. Nokia allows you to share all of your content in many different ways. Uploading your photos to Flickr, for example, couldn't be simpler.
Nokia.
All these experiences, so elegantly simple. It's what Nokia always has and always will deliver.
Nokia had 47% of the global market share for handheld mobile phones in 2007, with touchscreens and apps and email and internet and all those things that we have today. And now they don't exist except as a brand. They were disrupted by a company who never made a phone before. It's certainly not true that it's what Nokia always has and always will deliver. Even the companies with 47% market share, who have been around since, well, for over 150 years, like Nokia, can be disrupted. And why? Well, it's because of this. This is what you will come to appreciate in the next few days. Let's take a look at some examples. We've heard of Moore's Law. Gordon Moore made this observation in the 1960s to discuss the growth of chips. Just an observation. It's called Moore's Law. Others have come along and looked at that and said, this path, this curve, this exponential curve of chips is more than just chips. You can sort of look at computational stuff in general, and it is on an exponential curve. As a matter of fact, many technologies, not all, many technologies that become digital end up on this exponential curve. This is a fact. This is not anything other than that. This is an observation. As a scientist, that's what we do. We observe. Okay? Here's some examples. In 1997, a $55 million computer that did 1.3 teraflops. It fit in a room the size of a tennis court. So 1997, $55 million, 1.3 teraflops. A few years later, a Sony PlayStation 3 is $499 and it's 2.1 teraflops. And the US Air Force takes a whole bunch of those and puts them together to create one of the world's most powerful supercomputers using a bunch of Sony PlayStation 3s connected together, and they get 500 teraflops for $2 million. And Pi Zero is a little computer that's only $5 or less. Or, in other words, you can now either buy your Starbucks latte or have 2.5 Cray supercomputers as far as computing power goes. What was the most powerful computer in the world, you can now get that computing power for the price of a cup of coffee. And they're getting smaller, faster, cheaper, exponentially. And there's a virtual arms race of computing power with the world's fastest supercomputer now at 143.5 petaflops. Big numbers. What does it all mean? What does it mean when NVIDIA introduces products called brains that have 2 petaflops that just anyone can buy to do AI work on? Right? And we're moving into quantum computing. The notion of quantum simulation, being able to simulate everything, simulate chemistry. Imagine not having to be in the lab and mixing things anymore. Not having to do the simulation models that require physical work at all anymore. That's what the promise of quantum computing is. One of many. And then, of course, AI. We're hearing a lot about AI. Of course, it's been around since the 1950s. We've done things like taught AI to play chess or checkers, and it could. We taught it to play chess, and it did, and it beat a human. We've taught it to play a game show called Jeopardy that's very popular in the US. That's a little harder and different, and it beat the humans. And of course, we know with AlphaGo and AlphaGo Zero, the things we have read about, its ability to both learn from other AIs how to do things and simply observe. And wow, it's like magic with these different things. Yet, let's be real about this. This is all technology so far that's just been around since the 1950s, what we call narrow AI. Even the machine vision things that we're seeing started with the perceptron in the 1950s at MIT. So this is the long tail of the exponential here, right? AI, it started a long time ago, but it's only recently we're hearing more and more about it. But that perceptron box, that's the basis of us being able to know a dog or a cat on the internet. And we know AI can do that. It's been able to do that for a little while now. But now it can do things like this. You can have little consumer underwater drones that fly underwater and do real-time species recognition of the different fish as it's moving through the water. This is a $1,500 drone that swims in the water. You have AI doing things like this, and AI for child safety and security that looks into the social media of people to tell you if that would be a good babysitter for your child or not. Things like this. Let's take a listen to this.
So how can I help you?
Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd.
Sure, give me 1 second. Sure. What time are you looking for around?
At 12 p.m.
We do not have a 12 p.m. available. The closest we have to that is a 1:15.
Do you have anything between 10 a.m. and 12 p.m.?
Well, that's kind of interesting. That is actually an AI making the appointment. Wow. It was a human getting the appointment, but the AI was making the appointment for someone. That same 1950s technology, but the convergence of that and very good speech synthesis technology and a lot of computing power to do that make it feel good. There was also a clever trick in there by having the AI say, people believe it more, so be careful. By the way, in America now we have the Amazon Go stores. You simply walk in the store, pick up what you want, and walk out, and you're charged. And an AI is watching you, and it sees what you pick up and take and put back. Or if your child comes up and says, here, candy, and you take it at the last minute before you go out the door, and it charges you. And it's just all automatic, and it's all just doing this AI that's been around for some time. And other things that appear magical, Carnegie Mellon in work that uses EEG technology to look at simple brain waves, a 100-year-old technology, to read minds. So what you're seeing here in the top row is the picture that participants were presented with, and the images below are what the AI thought the human was looking at based on nothing more than the electrical output of their brain. Look how good some of those are. Fascinating work. AI is being used to design things. You're going to hear from Andre and Jason and Scott about generative design and how an AI can design the world's most efficient antenna. No human ever thought of doing it that way. Or other interesting things. You'll hear a little bit about this project in generative design and people like Airbus and how they're using it to do amazing, new, and interesting things. But these computers, they're moving. This is an exponential thing we're talking about here, right? So all kinds of stuff is happening, and computers are breaking out of that C prompt. For all you old folks in here, you know what that is up there. And they're breaking out. This particular AI, it went to art school. It studied art. It studied Rembrandt. And then it studied all the Rembrandts. And then it went out and it painted a Rembrandt. And people who know Rembrandt looked at it and said, hey, that's a Rembrandt, but I've never seen that before. How about this? Take a listen.
The traffic jam down on the ground.
That was written by an AI. It studied pop songs. This AI studied classical music and wrote this song. Pretty good for an AI. Amazing things. And then you hear phrases like the Internet of Things. It's not true. It's the Internet of everything. Over the next 2 days, just think of it that way. Think of it as we're basically building a nervous system for our built environment, for our infrastructure, for our things. With sensors, just like we have sensors, eyes, ears, mouth, nose, we're putting sensors and nervous systems in everything. That's what the Internet of Things, the Internet of everything means. Do not forget that, please, over the next couple of days. Know this, everything that can be digital will become digital. Okay? That'll be an important thing to keep in mind as we go here. Let's talk about robotics for just a minute. You're all familiar with robots. You've seen them. Of course, we have the Apple Daisy robot. This one takes things apart versus puts things together. We have robots that can do things like this. This particular robot can now do parkour. Right? These robots are getting quite good at doing this stuff. This, of course, is a robot. This robot drives us around. Robots are just a part of our life now. We've had these for several years in the Bay Area where I live. We have robots like this. You'll see things like this on the road from several different companies. What would you do if you saw this? Okay. Robots like this. This robot is an agriculture robot that looks at every plant individually to see how it's doing using the convergence of robotics and AI. This particular drone flies in and repairs potholes in the road. and then flies on and uses AI to find the next one. We have robots that are smaller than ants that people are developing right now. And of course, things like the vest that you've seen here today, and Samsung is making a version. Several companies are doing this stuff. And of course, you're going to hear from Jody about augmented reality and virtual reality, and you'll see how and think about how in the manufacturing sector, of course, this is a natural fit for the kind of things that you folks need to do. I don't even need to talk about that. It's so obvious. This might not be so obvious. Biology. Are you thinking about biology? You should be. It doesn't matter if you make cars. If you're in manufacturing, it is very likely in the future that biology will play some role in what you're doing. This was just announced a few days ago. This is the first time that researchers have been able to 3D print an effective cardiovascular system, or a synthetic system, that can actually sort of operate the way a human lung does, right? So what does this mean? It's one of the first steps, or one of the other steps that we need towards printing, creating human organs. But there are many other parts of biology that will play a role in whatever it is that you're doing out here. I mean, look, we're in the age now where we are literally able to edit genes. With CRISPR technology, we can go in and cut and snip DNA, take it apart and put it together. And these are early days for this, but this is where we're at. And it's more than that, because people are now looking at, can we take viruses and use those to transmit information? Because that's what a virus does. It goes to a cell, and it sends information to the DNA of that cell and instructs it to do something. Well, can we instruct it to tell it to do something good? Something that we want? Can we turn viruses into apps for the body? And there are people that are working on this kind of stuff. It all goes back to this. I'll say it again, this exponential curve. Now, here's the issue. We are not wired to think in an exponential way. Our world is fairly linear. Here's what I mean by that. If I asked, please don't do this. If I asked you all to stand up, and we'd all look this way, and we would take 30 linear steps. In other words, 1, 2, 3, 4. All of us would know where we would be, right? You would not have to do any math. I would say, yes, I'd be over there in the seats. I instantly know. But if I said, take 30 exponential steps, don't try to do the math. Just take 30 in other words, 1, 2, 4, 8, 16, 32. How far would I go? Don't think about it too much. Would I go 10 miles? 20 miles? 100 miles? 30 linear steps is 30 meters. 30 exponential steps is 26 times around the world. Do you see how you're going, huh? Right? Because your mind is, wait a minute, how is that possible? But that's the nature of the exponential, do you see? And our technology is growing at that rate. And keep this in mind. This is so important. How big was the last step? It was 13 times around in one step. Are you with me? So these steps sometimes seem very, very big. Do you remember the woman that we saw at the beginning? Sometimes these steps feel like, wow, what happened? What do you mean cars that drive themselves? What do you mean by robots that can do dancing and jumping like that? Of course, we know they've been around for some time. Again, that's the nature of the exponential. Here's a great example of that. 3D printing. We've all heard of 3D printing by now. Let's do an experiment. How many people first heard of 3D printing about 3 years ago? Okay. How about 5 years ago? 15 years ago? 30 years ago? Anybody? Wave your hand really if you really... Wow, are you surprised to learn that it was invented in 1983? Again, you said, wow, the long tail of the exponential. 1983, and it's going, and it's getting bigger. And down here, it doesn't seem like much, But then it starts getting up here, and it's big, 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 and before you know it, wow, and you're like that person at the beginning. Oh, what? No, stop. It feels crazy. And I see, but it's all good stuff, because look what we've done so far. We now have, in Southern California, the world's largest metal 3D printer, and their goal, this is a company founded by a person from Jeff Bezos' Blue Origin space company and Elon Musk's SpaceX company, and these two got together and started this company with the goal of 3D printing a rocket from top to bottom with the world's largest metal 3D printer. We started in 1983, and we've come to that. And you're going to hear more from Jason Dunn, my good friend from Made in Space, about a project where they are now building robots that will fly through space, 3D printing things that are large. Things that could be the size of football fields or larger are completely possible with this. And we've done that since 1983. That's how far we've come. Right? Now, here's what you have to remember as you hear from all our speakers today. We want to think like this. That's our vision typically. This is our technology. As we get to write about here, you can see that things get a little messy. This is disruption. Does that make sense? Disruption is where the tech is going like this, and you're just going like this, and you will get disrupted if you do that. You're going to learn over the next 2 days how to lift your gaze and look up there and plan for that and think about that. You don't have to be exactly right all the time. You just have to change your what? Your mindset more than anything. Learn about the ways to do this. It's possible. It's not just possible. It's critical. If you don't do this, the people who don't do this will not be able to participate quickly and in a meaningful way in the global economy in the future. Mindset is what's going to make that possible for people, right? So, let's keep in mind what we said at the beginning. Your view of things, they can change. You can go from the entire universe is just the Milky Way to what? There's a whole lot of them out there. And it's not just the big 3D printers that are printing rockets or the robots that are up in space that are printing giant things. It's much more than that. It's the kind of stuff you're going to hear today or hear over the next 2 days from people like John, who are truly making a meaningful contribution to people's lives, right? This is important. Look at this. And this specifically comes from Thailand. Am I giving it away to tell the story? The story that they realized when they were doing these, that there was no hand that was good at doing the Y with the thumb. And so they came up with a way to do that with this 3D printed hand at Enable. You'll be able to see this today. With that, I will say thank you so much. And before I do this, you heard it mentioned earlier, I had the privilege to work with Alan Kay at Apple when I worked at Apple. I hope you understand how true this statement is, that the best way to predict the future is to create it. And you're in a position to create Thailand's future. Obviously, the people in this room are in a position to do that. So with that, I will say, Sawadi krap, and I'll show you that we can do the right way by bringing the thumb in and saying Sawadi krap. Thank you.